The Kestros is a dart thrown by a sling, called Kestrosmendon. It was used by the Macedonians against the Romans. In one of my earlier videos I made a possible reconstruction. After experimentation and more research I concluded there is more to it, and today I will show you another possible design that is also true to the ancient description. The purpose of the Kestros is to achieve speeds and energies of slings and have a better penetration than stone or lead. If either task is not fulfilled, it can be replaced by either a sling or a bow, and all the effort to make a Kestros and sling it will be wasted. In my previous designs, the dart points outwards. This results in high drag during wind-up, which limits the speed. The range achieved is around 100 meters, which is inadequate to compete with simpler ranged weapons of the time. Another important problem is the angular momentum of the dart. This is a problem in every attachment point, center of mass, tail or point attachment. The dart has angular momentum and will fishtail after release, losing a lot of speed. The solution to high drag during wind-up is to have the dart go point first, but this doesn't solve the angular momentum problem. For the previous design to work, the fins had to be relatively big, and I carved a hook on the tail end that might be implied in the text. Kestros is a word used for the dart description, but the feminine version of the word would be Kestra, and it means a number of different things: a kind of fish, a feed, a hammer, or a bolt hammered in the torsion spring to create space to pass more rope. While reading about weighted ballista bolts, I stumbled upon a drawing of the Kasser Ibrim bolt. The theories are that this bolt could be a foreshaft or a bolt for a ballista or part of a grape shot. There are arguments why this is not a foreshaft, like the shape and number of fins. The argument why this wasn't shot with a bowstring is that it doesn't have a sturdy tail end and there are more aerodynamic options for ballistas. The name Kestros would be fitting for this bolt because it looks like a feed. Although the dimensions are different, the proportions of each part coincide with the description by Polybius. The fins are wooden, short and are attached to the middle of the wooden part. The sling called Kestrosmendon remains the same as in my previous reconstruction, which is a split pouch sling with a shorter release cord. The dart is inserted into the split. The center of mass rests behind the split, and the retention cord rests in the groove created by the fins in the rear. The release falls into the category of a Y sling or triangular slings. I can't find pictures of the bolts, but it's unclear if the fins are attached or they are one piece with the shaft. The drawings show right angles and the transition from the shaft to the fins. This seems difficult and unnecessary if the fins are carved with a chisel, but it is expected if the fins are wedged on. In the previous dart design, the fins and the fitting groove were difficult to make. The protruding fins would be cumbersome to carry in battle. In contrast, the new fin design is smaller and sturdier with reduced drag. It is easier to make because it can be carved out of the shaft, and in the case of wedging the fins, a saw can be used to make slanted slots instead of using more complicated tools required on the previous design. A modern dart design will not work because the fins will catch on the release. The fins should not be protruding from the shaft. Performance. Because the bolt is self-stabilizing during wind-up, the drag is low and it can reach higher speeds. The angular momentum can be cancelled by the opening of the pouch. Based on the two last points, the dart will experience low drag from wind-up to impact. To achieve high speed with a sling, the projectile has to be light like the Kasser Ibrim bolt. Problems. The wedged fins design is flimsy and seems unreliable. Carved fins are more reliable. The dart stays point first during wind-up and twists the sling cords, which can increase delay of the release and throw the shot off and start fishtailing. A way to combat this would be to pre-twist the cords a certain amount of times so that they are untangled exactly when you want to release the sling. This is a problem that arises when we make the arrow stay point first through the wind-up, which seems to be important if the goal is low drag and high speed. From experiments, it has become clear that there is a certain amount of skill required to use a Kestros. The reload times are slower than a sling, which means the Kestros would be used at long ranges or against pinned down enemies that require more penetrative power than lead and arrows. I haven't been practicing enough and I do the common mistake of pulling late, which pulls the dart out of alignment. Then it fishtails. Ideally, the arrows will be better designed than what I have and will leave the sling point first. Then there will be no fishtailing. A similar inline sling would be a 4-cord sling. This sling may work with certain arrow designs, but the loading is more difficult and slower. It doesn't work with these darts. An idea might be to spin the dart to increase stability, but it seems unlikely. I would expect to consistently result in fishtailing. Ending points. Pictures of the Casseret brim bolts may shed some light on how the transition from the shaft to the finish is made. Better made darts and slings should be tested. I'm gonna continue with this. No fins. The whole head. Two fingers. Okay, each one span.